Hello, let's discuss array operations question from today's CodeChef Charters 180. You are given an array of n positive integers a1 and so on n, where n is odd. You will perform the following operations repeatedly until only one element remains. Choose any three consecutive elements in the array, say example ai plus 1, ai plus 2 for some valid index I. Remove these three elements and replace them in the same position with a single integer equal to maximum of ai plus 1, comma ai plus 1, comma ai plus 2 plus 1. Your task is to determine the maximum possible value of the final remaining element if you perform the operations in an optimal order. You will be given t test cases, and each test case will be of the first line a single integer n, and the next line n spaced separate integers. So the given question says that you are given an odd length array. You can select any index I and you can replace with maximum of before value plus 1, after value plus 1, and present value. We can replace the present index with this value, and finally after doing some operations we have to find the maximum possible element possible at that index. So let's take an example. Let's find how many operations are required to convert the given odd sized array to a single integer. So if the given array has only one element, it is already a single element, so no operations are required, so it is 0. And if the size is 3, we can do one operation for the middle one, so it will be one operation to make a single element. If there are 5 elements, we can convert any 3 to 1 by using before operation. So after doing that, again a 3 sided array will be formed, and again operation 1 can be done. So finally 2 operations are required to make it of length 1. So based on this, we can observe that the number of operations required are n minus 1 by 2 to make a single integer. Let's use this as k. The next thing is, what is this operation and why it is so useful here. So to change the maximum value of the array, this is the only thing we can do by selecting the indexes optimally. So if we observe this more carefully, if the initial array has maximum element mx in the initial array, so when can we increase it? We can increase it only if it is at before index or after index from the chosen index. Because if we select the maximum element index first, it should be replaced by before value plus 1, after value plus 1, and mx. So it will be surely less than or equal to mx, as initially this is the highest element. So for example, the array is 512, and we are trying to, and the only operation possible is to take the middle element. So if we take the middle element, the 3 can be replaced by maximum of 6 comma 1 comma 3, which is 6. Similarly, if there is 1 to 5, we can select 2 and the number becomes maximum of 3 comma 2 comma 6, and which is also 6. But if there is 152, we can select only this value. So the maximum value possible now is maximum of 2 comma 5 comma 2, which is 5. So based on this, we can observe that we can increase the maximum value of an array only if it is at leftmost or rightmost in the selected index. And if we select the maximum element as the index, even now the value can be less than or equal to mx, but we are not incrementing it. So the best optimal choice is to take the next element or previous element of the maximum number in the given array. So let's take another example. Here is a 7 sided array, and initially this is the index of maximum element. So as we discussed here, it should be rightmost or leftmost of the taken operation. So for example, let's take this one where the maximum element is the leftmost index. We replace this by a single number, and this will be mx plus 1, as here mx is 5 and the new one is 6. So here the new one will be mx plus 1. And now similarly we will take these three because it should be rightmost or leftmost, and now it is rightmost here. So we can replace this by a single integer, which is mx plus 2. So now finally there are only 3 elements left. So as we discussed here, If the element at the middle index is highest, we cannot increment it. If the maximum element is this or this, then we can increment our answer. But as per this example, the maximum element is here itself, so we cannot increment it anymore. To observe some more thing, we can check the index of highest element. Initially, the index of highest element is 3. After doing any operation, as we discussed that it should be rightmost or leftmost, its index will be same or will be decremented by 2, because here it is 3, and if we select these 3, index is 3, 4, 5, these two elements just will be cancelled, and all indexes from this will decrement by 2, because these two elements are reduced, and there will be no effect till third index. So similarly here we are selecting these two, so after these all indexes will be subtracted by 2, and there will be no effect till 0. So here it is 3, and these both elements are removed, so it will be in the first index. So after, if the initial size of the array is n, and we can find the index of maximum value, and we can also find what will be the index of the maximum value after all the operations when it is converted to size 3. So if the index is 0 or 2, we are sure that we can increment the maximum value also then, and if it is the middle, we cannot convert into the next possible value. So what is the algorithm? Initially the number of operations we can make is n minus 1 by 2, which is k. So if the array size is n, so let's say for example the array size is 3. So in k operations we can make it to a size 1. So in k minus 1 operations we can make it size 3. So in all these k minus 1 operations, we are sure that we will select a size of a subarray of size 3, where the maximum element is rightmost or leftmost, and we can replace that with the mx plus 1. So in all these operations, the maximum value will be incremented plus 1 for sure, but it is doubtful in the last operation, because if it is at the index 1, we cannot increment it, else we can increment it. So let's see the code. We are taking t-test cases and inputting the elements and the size. We are finding the maximum value and index. So for auto ITV, we are finding the maximum value, and the number of operations is k, which is equal to n minus 1 by 2. So it is n minus 1 by 2. Bool b is equal to 0. What is b here? So we are checking what is the parity of the maximum value. Parity indicates whether it is at the odd position or at the even index. So we are traversing through all the array at even indices, because we are starting from 0 and incrementing 2 every time. So it will be 0, 2, 4, 6, 8 and so on. So if it is equal to maximum value, it is at a, let's assume it is a b is equal to 1. So if we find it at even index, we are making is b is equal to 1, because if according to this, initially at I is equal to 3 we have maximum value. So initially I is equal to 0. Is v of 0 is equal to max? No. Is this max? No. Is 4 max? No, and so on. So based on this, we will never reach third index. So finally we are sure that we are not able to increment the last maximum value. So we are traversing all even indices, and if we find it, we are making b is equal to 1, so that it will be at the 0th index or 2 index after converting to size 3. So int answer is equal to mx plus k minus 1. So for all k minus 1 operations, it will be incremented once for sure, and if b is equal to 1, then we can increment one more time, else we cannot increment it. So finally we can print the answer. If there is a doubt that there can be many occurrences of maximum value, this will even work, because here we did not do the opposite case. What? So if for example we are traversing this, and if we find the maximum value at even index, we are not breaking the loop. We are doing this for this, because we want any one maximum element at even index, so that we can use that as a maximum element possible, and we can reduce all. So if it is only one maximum element, it should be at even positions, And if there are many occurrences of maximum value, any one at even indices will be sufficient to convert into maximum value. So it will work here as well. Drop a like and comment below if you have any doubts. See you in the next one.